Okay, welcome back, everyone. We are going to be looking at the adrenal gland now. And remember the adrenal, when we look at the word adrenal, we see the word renal, which means kidney, and the prefix AD, you're adding something to it. What is it you're adding are these two glands right here, the left and the right, adrenal. Sometimes they're referred to as suprarenal glands as well. When we look at the adrenal glands, we have an outer portion and we have an inner portion. The outer portion, remember, just like the outer covering of a tree, that's called the bark. That's the cortex. That's what cortex really means, the bark. And then the inner portion is the adrenal medulla. So we have the adrenal cortex, and then we have the adrenal medulla. Both of these parts of the adrenal gland are going to be responsible for pushing out different types of hormones. The adrenal cortex is going to push out glucocorticoids, and they're going to push out mineral corticoids. The glucocorticoids, the biggie, remember, is cortisol. And then the mineral corticoid is going to be aldosterone. And the mineral corticoid for aldosterone, it's going to be its primary job is to try and retain and hold on to sodium, where at the same time it's going to try and kick out potassium, right? Remember the sodium potassium pump? There's kind of always like an inverse relationship between the two. So the adrenal cortex can push out glucocorticoids. The biggie is cortisol, cortisone, corticosterone, and then a mineral corticoid called aldosterone. Aldosterone is involved in retaining sodium. When I think of the adrenal medulla, that's where I think of adrenaline and noradrenaline, or epinephrine and norepinephrine. So this shows up quite a few times on the lab portion for the histology portion, and you need to be comfortable with the different parts of the adrenal gland. So the cortex is divided into the three regions: the zona glomerulosa, which is the most superficial, the zona fasciculata, which is the middle layer, and then a zona reticularis is the deepest. So these three portions here are part of the adrenal cortex. The zona glomerulosa, which is this portion from here to here, right? That's going to secrete the mineral corticoids, mainly aldosterone. You should be thinking sodium with that, sodium retention. This thick portion here, from here to here, this is the fasciculata, and that's going to deal with the glucocorticoid, mainly cortisol. And then the deeper portion, which is from here to here, that layer is the zona reticularis, and that's going to make androgens, sex hormones like testosterone. Once we're deeper than that, now we're in the medulla, right? So the adrenal medulla is going to make your epinephrine and norepinephrine, okay? So good slide to go back to look at. So the zona glomerulosa makes the mineral corticoid, the zona fasciculata, the glucocorticoid, and the zona reticularis makes the androgens. The glucocorticoid, we're thinking cortisol, and the mineral corticoid, we're thinking aldosterone. So aldosterone is the major mineral corticoid, and it helps to regulate sodium and potassium homeostasis, retains sodium and kicks out potassium. So with the adrenal glands, we're going to talk about the renin, angiotensin, aldosterone pathway. Okay, sometimes it's called the RAAS, the renin, angiotensin, aldosterone system. When we look at these words, right, renin, the first few letters of renin are rene, for renal, so this involves the kidney. When we look at angiotensin, we see tensin, which sounds like tension, and angio means blood vessel, like angioplasty and angiogram. So we have the kidneys involved in regulating blood vessel tension, and aldosterone, we know that that's the mineral corticoid that's going to be involved in retaining sodium. So let's take a look at the RAAS pathway, and let's see how it all works, okay? So we have something that's causing decrease in blood pressure. Number 3, we have a decrease in blood pressure, probably because they're a little dehydrated, they're a little bit low on salt, or maybe they're losing blood and they're hemorrhaging. So if they're hemorrhaging, there's going to be decrease in blood volume. If there's decrease in blood volume, you got decrease in blood pressure. All the blood is being filtered out by the kidneys. And the kidneys have these cells called juxtaglomerular cells. These are parts of the nephron. When you get into renal system or the kidneys for anatomy and physiology 2, you're going to learn about the nephron, and you're going to learn about the JG cells. The JG cells stand for juxtaglomerular cells. These are like sensors, and they sense that, there's some decrease in pressure. That's not a good thing. So what the kidneys do are the kidneys are going to release renin. Remember, renal, renin. Now, what is the renin going to do? Well, if we look off to the left, we have our good friend the liver here. And the liver makes angiotensinogen. Now, you've heard me say in a few lectures before that anything that ends in ogen, is it active or inactive? We know it's going to be inactive. So angiotensinogen is an inactive chemical structure that needs to be activated. So renin bumps into angiotensinogen. It's going to knock off the ogen, activate it, and become angiotensin 1. Angiotensin 1. Now, if there's an angiotensin 1, it's safe to assume that there's probably going to be an angiotensin 2. But how do we go from angiotensin 1 into angiotensin 2? Well, this is where our good friend the lungs come into play. So angiotensin 1 goes into the lungs where we have an enzyme called ACE. And ACE stands for angiotensin converting enzyme. It is zinc dependent. We need zinc in the lungs. Now, angiotensin 1 goes into the lungs. You have zinc. We have good amount of angiotensin converting enzyme. Angiotensin converting enzyme converts angiotensin 1 into angiotensin 2. Now, what is angiotensin 2 going to do? Well, angiotensin 2 is going to constrict your blood vessels. It's going to constrict your blood vessels. So if you constrict your blood vessels, blood pressure is going to go up. It is also involved in releasing adrenocorticotropic hormone, ACTH. We know adrenocorticotropic hormone, adrenocortico. It's going to be involved in secreting cortisol that's going to increase your blood pressure. It's going to be involved in aldosterone stimulation. Now, what does aldosterone do? Aldosterone is going to allow you to hold on to sodium, right? Think of salt, NaCl. Hold on to salt. You hold on to salt, you hold on to water, blood pressure goes up. ADH. antidiuretic hormone. All these things are happening because of angiotensin 2. Angiotensin 2 is going to stimulate antidiuretic hormone so that, hey, whatever water is in your body, you're going to hold on to it. Again, blood pressure goes up. Remember, we started with decrease in blood pressure. Now, all of these constricted blood vessels, aldosterone, ADH, and innately, you are going to crave NaCl. You're going to crave salty things, and innately, you're going to get thirsty. So you crave potato chips and pretzels. You're craving something salty. People go, I just need something salty. I don't know what it is. I need something salty. And then when you have something salty, you're thirsty. So you're having salt, you're drinking water, and the salt and water that you're consuming, you're holding on to the salt because of aldosterone. You're holding on to the water because of ADH. All of these have a way of increasing your blood pressure. Okay? So here it just shows angiotensin 2 going to the adrenal gland, going to the cortex. You're going to increase aldosterone. You're going to increase sodium retention. You're going to increase blood volume, and blood pressure returns to normal. I just went into a little bit more detail. These up here. Pretty cool. When we come back, I'll talk about how stress can kill.